This is the lesson for Thursday, 11/12. We're taking a look at doing the same thing we did yesterday with parabolas, only we're going to do it with x to the third. So let's just talk quickly about x to the third. X to the third is a parent function, which we don't need to know much yet. We'll talk more about that next week. Instead of it going up like a parabola on both sides, it goes down on one side. X to the third. So we're talking about 1 to the third is 1. 1 comma 1. 2 comma 8, because 2 to the third power is 8. We'll talk more about that next week. But what happens when you add other terms in, like in our example, is that this curved graph ends up looking something like what you see in the graph on the right there. And it has what I call wiggles. And instead of like a parabola where you have one maximum or one minimum, it has a maximum and a minimum, called a relative max or min. And so what we're going to do is we're just going to do the same things yesterday, just sketch the graph, get the key points, but instead of just a vertex, we're going to start by getting the min and the max. The way you do that, I'm going to show you on the calculator, is the same way that you got the vertex before. So let's learn how to type this in. Now watch my keystrokes. I'm going to hit X, and then I need to use the arrow symbol. Now there is an x to the third on here, but it is much easier just to use this caret symbol for higher orders. Okay, so I'm going to hit this caret symbol, and it makes a little box for the exponent, and I'm going to type 3 in. Now look at my cursor, it's still up in the exponent. So you have to hit, listen, the right arrow to get it out of the exponent. Then I can type the rest in. Plus 4x squared minus 4x minus 16. Now let's graph this. And you can see there's the graph, and I have a max and a min. Now we're going to find this the same way that we have found maxes and mins before. It's F5 G solve, max, to find the maximum, and you can see it's about negative 3.1 comma 5.1. It's a relative max. We'll talk about that in a second. And then hit G solve min to get the minimum. So you're doing both min and max on each of these. And that's the 0.4 comma negative 16.9. They're called relative because this point is not the maximum. It's not the highest point in the graph. The highest point in the graph is infinity because this graph goes forever. But it is a relative max, which means it's the maximum for that relative area. And this is the minimum for that relative area. Okay? So those are the two key points that you need. Now really, the only numbers we need from those are the x values. Negative 3.1 and 0.4 are the key numbers, the x values from those points. Now you are going to draw a sketch. I did it on the calculator, but you'll just draw it and you can just label it. Negative 3, 5. So I'm at negative 3.1, 5.1, and at 0.4. So if this is 1, so 0.4 comma negative 16. And I don't need too many details, but just show it going up. So again, we read a graph from left to right. So we go up, hit the maximum, go down or decrease, hit the minimum, go up and increase. Okay? So let's see what the domain range increasing, decreasing intervals are. For x to the third, this will always be true. Domain is the same as those. It goes forever to the left. It goes forever to the right. Both directions. There is no restrictions. You can put any x in. So this is the same as x to the second, the quadratics. However, the quadratics went only so far down. It went up in both directions. Because these are going up and down, the range is also all real numbers. And that will always be the answer for x to the third. You can see it's going down forever, going up forever. Going down forever, going up forever. So it's going to go from negative infinity to positive infinity as well. So those should be easy. But then what about the increasing, decreasing? My graph increases until it hits that x value of negative 3.1. And then it decreases until it hits that minimum, which has an x value of 0.4. And then it increases again. So where is it increasing? From negative infinity until I reach negative 3.1. Let me do that in a different color. From negative infinity until it reaches that x value of negative 3.1, it's increasing. After 0.4, so from 0.4 to infinity, it's also increasing. So I can say from negative infinity to negative 3.1, it's increasing, and from 0.4 to infinity, it's increasing. You could also use inequalities. Everything less than negative 3.1 is an increasing interval, and everything greater than 0.4 is increasing. Now let me switch to blue for the decreasing. The only place it decreases is from the max down to the min. Negative 3.1 to 0.4. From negative 3.1 to 0.4, this interval is where it's decreasing. I can also write that as an inequality. Those compound inequalities, saying that when x is between negative 3.1 and 0.4, that's where it's decreasing. Okay? I do have another one of it going the opposite direction. Notice on this one, the a value is negative. So instead of it going up, down, and up, it's going down, then up, then down. Now the domain and range, and again, you get the mins and maxes the same way. Okay? The domain and range are still the same, all real numbers. There's nothing restricting x or y from existing for any number. But the increasing and decreasing are what we need to focus on here. So it's decreasing until it hits that x value of negative 0.9, that minimum. So it's decreasing until I hit an x value of negative 0.9. And then it decreases also after the maximum, which was also a 0.9. So from negative infinity to 0.9, negative 0.9, it's decreasing. From negative infinity down to negative 0.9, it's decreasing. From an x value of 0.9 to positive infinity, it's also decreasing. So again, everything to the left of this, it's decreasing until it hits 0.9 or less than negative 0.9. And then it's decreasing after the maximum, so greater than 0.9. The only place it's increasing is between the two. It's going up before it goes back down again. So between negative 0.9 and 0.9. Between negative 0.9 and 0.9. Okay, if you have questions on this, you want to go over a little bit more, pop back into the session and I will go over it with you. Give the homework a try and see how it goes.